Let's look at an expansion problem. Let's look at 1 plus 2i cubed. Well, 1 plus 2i cubed means 1 plus 2i times 1 plus 2i times 1 plus 2i. I'm going to multiply these two together first. 1 times 1 is 1, plus 1 times 2i is 2i, plus 2i times 1 is 2i, plus 4i squared, times the 1 plus 2i. So I'm multiplying those two together using the for method. First, 1 times 1 is 1. Outside, 1 times 2i is 2i. Inside, 2i times 1 is 2i. And the last, 2i times 2i is 4i squared. Well, I get 1 plus 4i, 2i plus 2i is 4i, plus 4 times I squared is negative 1, times 1 plus 2i. Now 4 times negative 1 is negative 4, so I'm left with a negative 3 plus 4i times 1 plus 2i. Again, 4 times negative 1 is negative 4. Negative 4 plus 1 is negative 3. Then I've got 4i. Now I use the for method again on just these. A negative 3 times 1 is negative 3 minus 6i when I do the outside, plus 4i when I do the inside, plus 8i squared when I do the last. Negative 3 minus 2i, because the negative 6 plus 4 is negative 2, plus 8 times negative 1. Negative 3 minus 2i minus 8, which is negative 11 minus 2i. Now let's look at a division. Well, to divide radicals earlier, we had to multiply by the conjugate. Well, we're going to use exactly the same procedure to divide complex numbers. So to do 4 subtract I divided by 2 plus 3i, I'm going to multiply by the conjugate. So it'll be 4 subtract I over 2 plus 3i times 2 minus 3i over 2 minus 3i. I multiply both numerator and denominator by the conjugate of the denominator. Now I can use the for method on both of them. 4 times 2 is 8 minus 12i minus 2i plus 3i squared over 4 minus 6i plus 6i minus 9i squared. So that would be 8 minus 14i plus 3 times a negative 1. I combine the like terms, negative 12i plus the negative 2i is negative 14i, and I replace I squared by negative 1. Now in the denominator I have 4. This negative 6i and positive 6i cancel, so minus 9 times negative 1. Now 3 times negative 1 is negative 3. 8 plus a negative 3 is 5. So I have 5 minus 14i over. Now negative 9 times negative 1 is positive 9. And 9 plus 4 is 13. Negative 9 times negative 1 is positive 9. 9 plus 4 is 13. Or I can write my answer as 5/13 minus 14/13 I when I put it in standard form. Let's look at one more division problem, and then I'll give you some exercises. Let's look at 8 divided by 1 minus 2i. It would be 8 divided by 1 minus 2i times the conjugate of the denominator, which is 1 plus 2i over 1 plus 2i. Distribute the top. 8 times 1 is 8 plus 16i. 8 times 2 is 16. Over, use a 4 on the denominator. 1 times 1 is 1 plus 2i minus 2i minus 4i squared. 1 times 1 is 1. 1 times 2i is a positive 2i. A negative 2i times 1 is a negative 2i. A negative 2i times a positive 2i is a negative 4i squared. Where I'm left with 8 plus 16i times 1 minus 4 times a negative 1. A positive 2i and a negative 2i gives 0, and I replace the I squared by negative 1. So we have 8 plus 16i over 1 plus 4. 8 plus 16i over 5. Or I can now write it in the final answer form as 8/5 plus 16/5 I when I distribute my division over the addition. Now I'm going to give you some exercises. You're going to have to copy it as I move it because I couldn't get all these on the same sheet and you'll be able to read them. Perform the operation. The first one, 2 subtract the square root of a negative 4 times 1 plus the square root of negative 9. The second one, 1 minus 5i times 2 plus I. The third one, I divided by 1 plus I. I divided by 1 plus I. The fourth one, 2 plus 3i divided by 1 minus I. I'll let you look at them again. Now I want you to stop the tape, work the problems, and then restart the tape to compare answers. Here are the answers. If you disagree with any of these answers, be sure to check with someone. This completes your lesson on complex numbers.